I'd like to share with you the composition and results of an intervention trial that I devised as part of my PhD. And the PhD involved the creation of nanoemulsion systems, which I will explain to you in a while. And the use of these nanoemulsion systems with vegetarian omega-3 oils that were then added to functional foods with the aim of increasing omega-3 intakes in population groups with low intakes. So we're going to look at the trial that I did. So what we're going to talk about first of all, I'm going to give you some background into the trial. So we'll look at oily fish consumption first of all, and specific groups that need to improve their intakes, although as a whole the general population actually needs to increase their intakes. I'm also going to explain nanoemulsions, and I've got some pictures for you, so hopefully it'll help you to visualise what a nanoemulsion system is. Then I'm going to go through the materials and methods that I used for my trial. So that will involve how the functional food was created, the methodology, who I recruited to take part. Then we'll look at the results and the main findings, and then a couple of conclusions. So when I'm nervous I speak quite fast, so I'll try and slow down and not do it in 5 minutes. Okay, so to start with, you may or may not be aware that oily fish is the main source of long-chain omega-3 fatty acids in the diet, and these provide quite important health benefits. There are vegetarian sources, but the carbon chains are shorter, which basically means they don't give as good health benefits as these longer-chain fatty acids that we find in oily fish. And the important health benefits would involve cardiovascular health. Some researchers think that mental health is affected by omega-3 status, and also visual status, so maintenance of the macula at the back of the eye. That's just to name a few. Current UK recommendations state that we should be eating 2 portions of fish a week, and one of these portions should be oily fish, and it should weigh about 140 grams, and that's once a week. Oily fish would be fish such as mackerel, salmon, sardines, that sort of fish, so quite strong tasting fish. But at the moment, in the latest diet nutrition survey, which came out in May, we're only consuming on average about 56 grams a week, so there's quite a big shortfall there. Reasons why that might be, as I've mentioned, these oily fish, they're quite strong tasting, so there might be that people dislike them, or they can be quite tricky to prepare because they're small with lots of bones in them, or people might not be sure how they're cooked. Also, oily fish is a concern with regards to contamination with mercury and PCBs, so the rubbish that we put into the sea tends to be stored in the lipid part of the fish, which if we're consuming a lot of it, then that would be a concern, and that's also particularly a concern for pregnant ladies, because it can be passed into the child. Also, sustainability of fish stocks, I think we've all heard quite a lot about that recently, so in certain areas fish stocks are quite low, and we're taking more and more fish out of the sea, so there may be a need for an alternative. Looking at population groups, in the male population there is a problem with adult males, younger children and certain ethnic groups, so they all have low consumption levels. But vegetarians and vegans are particularly, they have particularly low intakes, vegans in particular because they can't get access to these longer chain fatty acids. You can use them for enrichment in eggs, but obviously if you're a vegan then it's no animal sources at all. And this is backed up by some studies that have suggested that omega-3 levels in vegetarians are 65% lower than they are in omnivorous people, so people who eat fish and meat. So that's the background to omega-3 intakes. Hopefully this has given you a bit of a rationale as to why I'm creating this functional food. If we move on now to the nanoemulsions, the more interesting part I think. Emulsion systems exist in quite a lot of foods, and a simple example to give you there would be milk, because there's milk fat and there's a water phase, so there's globules of milk and there's water phase as well. A nano or a nanometer is 1/1000th the size of a micrometer. So we're looking at a very, very small emulsion system here. I'm going to show you a picture after this, so if it's not flowing properly, hopefully it will help you when you see the picture. And a nanometer is 1/1000th the size of a micrometer. So we're looking at tiny, tiny, tiny particles, smaller than a red blood cell in a nanoemulsion. And to give you a range of sizes, so if you've got a cloudy emulsion system, which you can see on the far side, that's likely to cover the size range of about 500 nanometers. And if you can manage to get a clear system, which I didn't, it's quite rare, you've got to get very, very small droplets. You're looking at 50 to 200 nanometers, then that would make the system transparent. But most of them have a milky appearance. They look a little bit like milk because that's what they are, emulsion systems. The reason that we're looking at nanoemulsions is because they've got the potential to increase the bioavailability and stabilise reactive or sensitive ingredients. These small droplets have a large surface area, which in turn makes them more bioavailable in the body. The rationale behind that is, if you're using these oils, it can be quite expensive, so you could use a lower dose of the oil because it's a more effective system to get into the body, or you can use large doses effectively. So that's why. Hopefully that will visualise it for you a little bit. So what I did with these, I got my little emulsion systems in the lab and put them on microscope slides, had a look at them under the microscope. I had to dye them to get the colour. And on the left side you can see a coarse emulsion. So I've made this with an emulsifier and a mixer, and then I dyed the fat droplets red. So you can see all of these little droplets here are fat droplets in an a water system. So all the surrounding area is water. And the average measurement of all these fat droplets is 2.2 micrometers. Okay, and then blasted the emulsion with some ultrasound, which breaks up the droplets and makes holes in the middle like a donut and smashes them apart and makes very small droplets. And I think that demonstrates it quite nicely. It's gone down from 2.2 micrometers to 258 nanometers. And you can see they're very tiny, tiny droplets there. So we've created a nanoemulsion system. So what the PhD did was combined these two theories and designed a functional food that is aiming to increase the omega-3 levels, but using vegetarian oil, so it would be suitable for vegetarians and non-fish eaters. So if we have a look at this is what I created. So I created a functional yogurt drink vehicle. I use yogurt because it's easy to give it in vast quantities. I could have used milk, but there were some issues with oxidation there, so I used yogurt and I made a yogurt drink, so you could drink it quickly and get quite a large dose into my participants. I created the nanoemulsion and used it to enrich a strawberry yogurt drink, and you can see my materials along the bottom. It's quite a simple procedure. So the nanoemulsion was created using 50% algae oil, which contained a very, very long chain omega-3 fatty acid, but it was from a vegetarian source. The fatty acid is called docosahexaenoic acid, but I've abbreviated it to DHA. So anytime you see DHA, that's what it means. But this is a very effective long chain omega-3 that has health benefits. I think that's all you need to know at this stage. I also added a natural strawberry flavouring and some agave nectar for a sweetener. And the end product was eligible for EC health claims in relation to cardiovascular health and the maintenance of normal vision as well. And I've just popped a nutrition label in there so you can see the nutritional composition of my yogurt drink. 200 grams was the amount that I gave to my participants, and that gave them 1,264 milligrams of this DHA, this very long chain fatty acid that I was measuring and that is important for health. Okay, so moving on to the trial. So I recruited around Manchester Metropolitan University participants ranging in age from 18 to 60 years, non-smokers, and no pre-existing conditions or not taking any medication that could affect their ability to absorb lipids or metabolise lipids. Also, no one who'd been pregnant in the last 12 months. I use fingertip blood sampling in my trial, which is being increasingly used in nutritional trials at the moment. So I needed participants that would be able to give me 6 samples on each tranche of the trial without feeling faint or passing out. That would be a bit of a problem. But they were all fine, but I had to ask them if they had any issues before I got them to participate. I had to also get them to refrain from eating breakfast before they had their blood measured for each day of the 3-day treatment cycle. So I did them first thing in the morning before they'd eaten. That was the first blood test. I also had to ask them not to consume any oily fish or omega-3 supplements or any other sources of omega-3. So if they did consume regularly oily fish or take supplements, I had to put them on a washout for 4 weeks to lower their levels so that I could see a difference with this trial. So I was checking whether this was bioavailable or not. And also I had to ask them to complete 2 treatment cycles, which I'll explain in a minute, with a further 21-day washout period for omega-3 in between each trial, if that makes sense. So once I'd got them all recruited and washed out, I conducted a randomised single-blind crossover trial. And when it means randomised, the treatment was randomised, so some of them received the Nanoemulsion treatment first, some of them received bulk oil in yoghurt first, and then I swapped them over, hence the crossover trial. As I said, 2 treatments were given. One was the Nanoemulsion enriched yoghurt, and then I made another product that was very, very similar to the first one. It had exactly the same components, but the oil wasn't treated, it was just added directly to the yoghurt. It was very simple, but it was checking whether the Nanoemulsion against the bulk oil was effective. Obviously the trial received ethical approval and it was conducted in accordance with the Declaration of Helsinki. The subjects were randomised and allocated to a treatment pattern using a sealed envelope, which is like an internet source that will randomise everything for you. Baseline blood values acted as the control, so I checked the blood levels before I fed them these yoghurt drinks, and they acted as the control to see whether there are any differences in blood levels. I actually used the Omega blood count fingertip test kit, which you can see there. That was used 6 times for each part of the trial. A bit more on trial design. So I asked I don't know whether I should have done this or not, but I did. I asked the participants to rank the yoghurt in terms of sensory properties. And I did this with the bulk oil enriched yoghurt and the Nanoemulsion enriched yoghurt to see if there was any difference between the 2. As I mentioned, blood samples were taken at the baseline, and then we took them after 2 hours after ingestion, 4, 6, 24 and 48 hours following ingestion of the yoghurt. And then the trial was repeated with a second treatment, however it was randomised after a 28-day omega-3 washout. The blood values were baseline adjusted, so I took the baseline values off, and then I worked out the difference between them using the area under the curve calculation, which is a standard method that's validated for checking the bioavailability of drugs in different formulas. Hopefully my graphs will explain it a little better at the moment. And I used statistical analysis with SPSS, so mixed models ANOVA, because it was a crossover trial, and also a paired t-test to compare for significance. These are the tests that I completed, so there's that big long word that I used before, docosahexaenoic acid, which was what the oil was comprised of. And that's lacking in the diet of non-fish eaters. But these fingertip blood sampling tests enabled me to check for 6 variables in all. So the main ones that I had statistical results were the DHA, total omega-3 levels in the blood, and the ratio of omega-6 to omega-3. And that's important in health status. So if you've got higher levels of omega-3 than omega-6 in your blood, then you're more likely to be more healthy, according to the literature. So that's what I checked. Down at the bottom I also checked 2 other sources of omega-3, but the results for those weren't significant, but I've put them on there for information. So, onto the results. So you can see from my graph there, we've got the bulk oil, which is the block line, and the Nanoemulsion, which is the broken line. And when I said I checked area under the curve, it's the area underneath the line. So it's the actual area of the trapezoids underneath the line that I measured for this particular part of the test. We did statistical analysis and we found that DHA from the nanoemulsion was significantly more bioavailable than the bulk product for 2 and 4 hours following ingestion. It was quite a big difference, and I wish I'd have checked it after an hour now, because it'd be interesting to see whether it had actually gone up to its full potential, or even half an hour. So that was the DHA. And then we've got the total omega-3 fatty acids, so not just that particular one, but all of them in the blood. And this one peaked a little bit later than the DHA, but we still have statistically significant results 4 and 6 hours following ingestion for total omega-3 results there. And again, that was calculated using the area under the curve. And then we've got the omega-6, omega-3 ratios, and you can see there that the ratio decreased, which is good, very good for health. So people's levels of omega-6 came down and their levels of omega-3 went up. And that was statistically significant for the whole treatment, not just after 1 or however many hours. So that was the blood results. And then I had a look at the sensory results. So there's always a payback, isn't there? So I checked the attributes of the yogurt, the strawberry yogurt, the bulk, and the nano-emulsified or nano-emulsion enriched, and found that there were differences. It wasn't liked as much, the nano-emulsion wasn't liked as much as the bulk oil enriched. And there were significant consequences for the the aftertaste and the overall acceptability was significantly affected by adding this nano-emulsion. And I think that's really got to do with these small droplets. So you've got a large surface area which hits the tongue, and you can really taste the oil in the nano-emulsion. It was quite mouth coating as well. So that's my theory there. There's other theories, but I won't go into those today, it's a bit complicated. So my main findings were that the fingertip blood sampling method worked very effectively for the purpose of the trial. It saved me having to use cannulation and leave people for 3 days with a big valve stuck on their hand or in their arm. So that was a very effective use, and it was quite cost effective as well. The consumption of the yogurt drink enriched with the nano-emulsion of the DHA algal enhanced the bioavailability of the DHA, the very long chain effective omega-3 fatty acid, total omega-3 fatty acids, and it also reduced the omega-6 omega-3 ratio, which is quite beneficial to health. There were no adverse effects reported after consumption of either treatment, so there weren't any sort of drawbacks at all in terms of the participants. And the sensory analysis demonstrated that the nano-emulsion didn't affect the appearance, aroma, flavour, consistency and texture of the yogurt product, but it did affect the aftertaste and the overall acceptability. So there was something there that the participants weren't really keen on. Okay. So the conclusions. The study demonstrated that when we compared a bulk oil enriched yogurt product to a nano-emulsion enriched yogurt product, the DHA was more available, and total omega-3 was more available, and there was also a reduction in omega-6 and omega-3 levels. So it was quite a successful trial. And these findings indicate that there is potential for nano-emulsion enriched foods to increase the intakes of these groups that have low intakes, that don't eat oily fish. We need larger and more extended studies to prove whether this is the case. So that's me, that's my references, and I've just got some acknowledgements there. So I had 11 trial volunteers, and my fingertip blood sampling was all measured and analysed at Stirling University, and then we've got my supervisory team there on the bottom as well. And then that's a picture of the toe track where I did the trial. So that's it.
Okay, thank you very much. Very nice, 20 minutes, just less than 20 minutes.
Was
so
it?
We've got 3 minutes for questions. Has anybody got any questions for Kate?
Yeah. I was just wondering whether or not, is algal a better source of omega-3 than flax or like chia seed?
Yes,
yeah.
it is. Flaxseed, when I was talking about chain lengths, flaxseed oil has alpha-linolenic oil, which is a shorter chain length than this DHA I was talking about. So although your body can, in some cases, convert it to the longer chain in situ, it's better to have a direct source of it. So yeah, this is better.
Rick?
Can you tell us any more about the taste differences? What specifically was the difference in taste? Or
It was. I don't know how much you know about oxidation of oils, but I think it may have had something to do with it. I was using ultrasound, and it's quite a. You can't touch this ultrasound probe with your hand. You're not supposed to touch it. It causes cavitation, so it will make a hole in the oil droplet, and it causes temperature rises as well. I did oxidation testing, which is another talk, and I didn't find any differences if it was stored in the fridge, but that was just the test methods that I used, and I think if you use other test methods you might detect oxidation, and I think that was why it tasted funny. It tasted quite bitter. So yeah.
So does that mean there's implications then for shelf life if this product, if you produce a product, there's shelf life implications then?
Possibly. I've only read one paper that talks about ultrasound and oxidation, and it would suggest that it happens quite quickly during the ultrasound process. So once it's done, it's done. But I didn't find anything like that, and I did shelf life studies on it, and it was all fine. It was all safe to eat, otherwise I wouldn't have been able to give it to my trial participants. And also oxidation breaks down these carbon chains, doesn't it? So I think I would have noticed that it wasn't going into the blood as well if there was oxidation, so it's a big unanswered question. I'd like to do more to find out.
I mean, as this research project continues, I mean, you got so far, obviously, with some positive results, some slightly negative results in terms of acceptability. But what happens next?
Funding.
That's the funding, is the problem.
And also it's a patented system. The nanoemulsion system is patented, and that belongs to Manchester Met.
Oh, right.
So I have to do everything with them as well. So I have to collaborate with them to do anything. So it'd be nice if we've got a PhD student at Manchester Met that's using the method to create systems with plant stems and things like that, but it's not omega-3.
How's what format the bulk oil was? Was it capsules?
No, it was in yogurt. I just added it to yogurt. I did it exactly the same. So it had agave nectar, bacteria yogurt, and just took the bulk oil into it. So there was no difference in terms of appearance. Or the only thing with the nanoemulsion, it has some lecithin in it, which is like a stabiliser, so it stops it from splitting, to an emulsifier. But that was the only difference. That was a limitation because it had lecithin in it.
You put it into yogurt, which is quite a sweet product.
Yes.
What if you put it into a savoury product? Do you think it would have the same kind of sensory?
Possibly not.
Like mayonnaise or something.
Yeah. We did some trials with mayonnaise and sensory, but you don't tend to. I use a big dose.
You don't consume.
That's why I use yogurt, because you can get 200 grams of it into someone quite quickly if you drink it.
Like soup or something like that?
Yeah, you could. Possible.
Would heating the soup denatured the oils on?
Sorry?
Would heating the soup denature the oil somewhere?
It could, it could oxidise the oil. So you'd have to, that's, I was trying to keep it simple really to get the study done. So
it sounds like you've done it in yogurt. Shown that it works, it's just finding the acceptability.
There is a lot more that needs to be done.
I mean, are there other ways of getting this omega-3 that's damn sight easier?
Fish.
I mean, apart from fish oil, tablets, flaxseed tablets. Alan Hackett and Ian Davis were doing krill.
Krill's disgusting.
Krill oil,
this algae oil,
capsules.
it had no flavour to it. If I'd have nano-emulsified krill oil, it would have been really revolting.
The trouble with taking it in capsules and in these sort of more artificial forms is that to get the same amount of omega-3 you get from a 140 gram piece of fish, you have to, there's milks out there and things like that. You have to eat an awful lot of them to get the same dose as you would get in a piece of fish. So there's the dosage thing.
You don't digest a capsule the same way that you digest the food system. So it just can sit on the top of your stomach. So there's differences in bioavailability as well.
Plus there's other things in food matrices that are, there's vitamins and other minerals as well as macronutrients. You're always going to have in whole food.
Alright, I'll continue with the fish then.
Fish day.
No, it's alright, I mean, I love fish. It's getting hold of the bloody stuff, isn't it? That's the problem.
Funding, I'll carry on and I'll make you some.
I wish there was fishermen that came round once a week.
There used to be.
I know. Little fellas from Grimsby.
Even a can of most fish, apart from
sardines,
tuna.
a little tin sardines.
Tin sardines, mackerel, herring.
I once knew a bloke who every lunchtime, his lunch was a tin of sardines.
Yeah.
And literally every lunchtime.
So I do that sometimes, even a tin of mackerel. You see me in the staff room, just eat a tin of mackerel and some bread.
Yeah.
Yeah,
all right.
the one that smells and
Very antisocial.
well, just generally.
Okay, well thank you very much to all the three contributors.